All right, let's do something fun. We're going to step off our planet for a bit and take a look around. We'll get into the invisible forces that are constantly pulling on our oceans, creating massive shadows in the sky, and even how all of this, everything around us, came to be. Ready? Let's dive in.
Okay, so first up, let's talk about a rhythm that connects all of us, no matter where we are, directly to space. It's something you can see and feel. It's the steady, predictable breathing of our oceans.
I mean, you've been there, right? You're at the beach, you build an amazing sandcastle, and then you turn around a few hours later, and the water is either about to wash it away or it's retreated way, way out. It feels a little random, but it's not. It's a dance. And that dance has a partner.
And this right here, this is the reason why. It's the moon. The moon's gravity is always pulling on the Earth. Now, since water is, a liquid, it moves really easily, so it bulges out on the side of the Earth facing the moon. But here's the cool part. What about that second bulge on the other side? Well, that's inertia. As the whole Earth gets pulled toward the moon, the water on the far side kind of gets left behind, creating another bulge. Two bulges, not one.
So just picture it. The Earth is spinning, right? And as it turns, it passes through both of these watery bulges every single day. So if you're on the coast, you experience a high tide when you're in a bulge, and a low tide when you're in between the bulges. It's this beautiful, simple, and totally cosmic cycle. The thing is, this whole incredible dance is choreographed by just one invisible force. We've thrown the word around a bit, gravity, but what really is it? Think of it like the universe's superglue. It's this fundamental force of attraction. Anything that has mass pulls on everything else that has mass. The sun is huge, so its gravity is strong enough to keep all the planets from flying away. The Earth has a lot of mass, so it keeps you planted on the ground. And the moon, well, it's not as big, but it's got enough mass to tug on our oceans and create those tides. So here's the key takeaway. Remember those two tidal bulges? Well, since the Earth spins all the way around in 24 hours, any spot on the coast will pass through both of them. That's why you get a high tide about every 12 hours. Simple as that. Okay, so this gravitational dance is amazing, but it's not just about the tides. Sometimes the alignment between the sun, the Earth, and the moon is just perfect. And when that happens, they cast these huge shadows on each other, giving us some of the most spectacular shows in all of nature. And this is what we call a solar eclipse. It's when the moon slides directly between us and the sun. And for just a few incredible minutes, the moon, which is obviously way, way smaller than the sun, is at the perfect distance to completely block it out. It's just an amazing cosmic coincidence. And look at this diagram. What's so wild is how small and precise that shadow is. That's exactly why seeing a total solar eclipse is such a rare, once-in-a-lifetime kind of thing for most people. You have to be standing in that exact tiny spot on Earth to see day suddenly turn into twilight. It's incredible. All right, now let's flip the whole thing around. What happens when the Earth gets in the middle? That's a lunar eclipse. It's our turn to cast the shadow, and we cast it right onto the moon. And because the Earth is so much bigger than the moon, our shadow is absolutely massive. It's so big that the moon can take quite a while to pass all the way through it. And the best part? A lunar eclipse is visible to pretty much anyone on the entire night side of the planet. No need to be in one tiny spot. So let's put them side by side. It really just boils down to one simple question. Who's in the middle? If the moon is in the middle, blocking the sun, it's a solar eclipse. Sun, moon, Earth. If the Earth is in the middle, casting a shadow on the moon, it's a lunar eclipse. Sun, Earth, moon. Just that one little change in the lineup gives us two totally different and totally breathtaking events in the sky. All right, we have been looking really closely at this beautiful dance between the Earth and the moon. Now let's hit the zoom out button, way out. It's time to see where we fit into the bigger cosmic family, the solar system. And here it is, our cosmic neighborhood. Right in the middle, you have the boss, the sun. It's the star that makes everything else possible, and its gravitational pull is just immense. It's the force that wrangles all 8 planets, from little Mercury all the way out to distant Neptune, and keeps them locked in their orbits. And just try to wrap your head around the scale here. We think our year, 365 days, is a long time. But look at Mars. Its year is almost double ours. Then you get to Jupiter. That's over 4,000 days. And then, all the way out at the edge, Neptune, It takes almost 60,000 Earth days to go around the sun just once. I mean, wow. That's what distance and gravity do. So, the big question is, how did all this get here, this neat, orderly system? Well, it wasn't always like this, not even close. Let's wind the clock back, way back, about 4.6 billion years. We're going to follow the recipe for how to build a solar system. It pretty much comes down to 4 massive steps. First, collapse. You start with a giant cloud of gas and dust, and gravity starts to pull it all together. Second, spin. As it collapses, it starts spinning and flattens out into a big disk, kind of like pizza dough. Third, ignition. The lump in the middle gets super hot and dense, so hot that it bursts into life as our sun. And finally, formation. All the leftover stuff in the disk starts clumping together, building the planets over millions of years.
So this is where it all began. Not with a bang, not with planets, but with this, a huge, cold, quiet cloud of dust and gas just drifting in space. Scientists call it a solar nebula.
And then gravity starts to do its thing. It's relentless. It pulls everything inward. And as that cloud collapses, it starts to spin up, faster and faster, flattening out into this giant glowing disk. Right in the heart of it, the pressure and the heat just build and build to levels you can't even imagine. And then, bam, ignition. A star is born. And out in the cooler parts of that spinning disk, all the leftover dust and gas starts to bump into each other, sticking together, piece by piece, building up the planets that make up our solar system today. You know, what's really neat is that this whole process created 2 very different kinds of planets. Up close to the super hot new sun, only heavy stuff like rock and metal could handle the heat. That's how we got the small, rocky inner planets like Earth and Mars. But way farther out, where it was freezing cold, lighter stuff like gas and ice could clump together, creating those huge gas giants like Jupiter and Saturn. And that brings us right back to where we started. It's all about gravity. This one, single, elegant force is the architect behind everything we've talked about. It's what pulled that gas cloud together to build our sun and planets, and it is the exact same force that keeps our moon in orbit and pulls on our oceans to create the tides. So, from the gentle rhythm of the tides on a beach to the chaotic, fiery birth of our entire world, it's clear that gravity is the author of our cosmic story. Which really makes you wonder, doesn't it? What other secrets is it waiting to tell us?